Right, welcome once again to this lecture. Today we are going to look at the geometric distribution. The geometric distribution. Right, a geometric distribution arises when we have a sequence of independent, when we have a sequence of independent trials. So if we have a sequence of independent trials, let's say we try first chance, second chance, third chance, we have a geometric distribution. So under geometric distribution, we have probability of success, which is termed P. Then we also have probability of failure, which is termed Q. Right, let's take for example, let's say we want to find P of x equals to 1. Under geometric distribution we start from 1, but under binomial distribution and Poisson distribution we start from 0 number of trials. So if we have probability of x equals to 1, we use our probability of success P. Then if it is P of x equals to 2, we use Q times P. Then if it is P of x equals to 3, we use Q squared P. If it is P of x equals to 4, we use Q to the power 3. 4 minus 1 we get 3, 3 minus 1 we get 2 times P. Therefore, in general, if we have P of x equals to n, we use Q to the power n minus 1 times P. Right, so that will be our general formula for geometric distribution. Right, so for a geometric distribution, where n is 0, 1, 2, 3, 4, 1, 2, 3, 4, 5. Example, let's have an example. If x follows a geometric distribution with probability of success 1 over 4. So the distribution here is x follows a geometric distribution with probability of success P. That will be your distribution. If x follows a geometric distribution with probability of success 1 over 4, find P of x equals to 3. Find P of x equals to 3. Right, solution, we can see here that our P is equal to 1 over 4. Therefore, Q is equal to 1 minus P, which is equal to 1 minus 1 over 4. That will be 3 over 4. Then by formula, P of x equals to 3 will be equal to, remember we said n minus 1, that will be n, or we can use x here. P of x equals to x. We use Q to the power 2 times P, which is equal to, our Q, remember, is 3 over 4 squared times P, which is 1 over 4, right? That will give us 3 over 4 squared, that's 9 over 16 times 1 over 4, which is equal to 9 over 64. So this is how we find P of x equals to 3, right? So under geometric distribution, we have some important results that we can use. Let me just give you some results that we can use under geometric distribution. Let me quickly write these results. Right, some important results. Right, result number one. Let's say we are given for x follows a geometric distribution. If x follows geometric distribution with probability of success p, right? Result number one, if we want p of x is greater than r, that will be q to the power r. Remember, our q is 1 minus p. Our q is equal to 1 minus p. Then result number two, let's say we are given p of x is greater than a plus b stroke p of x is greater than a or b. This one, b and b will cancel each other, so we will remain with p of x is greater than a, and remember this one will be the same as this one, that will be p q to the power a, right? So number three, we have p of x is greater than or equal to r. P of x is greater than or equal to r. This will be the same as p of x is greater than r minus 1. That will be our result number 3. Alright, so we want to have an example for this one. Let's have an example. We want to use these results. Right, example number 1. A coin is biased. A coin is biased so that the probability of getting a head, so that the probability of obtaining a head is 2/3. If x is the random variable, if x is the random variable, comma, the number of tosses, the number of tosses including the first up to and including the first head, find a p of x is less than or equal to 2, p of x is less than or equal to 2, b, p of x is greater than 4, p of x is greater than 4, c, p of x is greater than 7 stroke x is greater than 3. Alright. Our solution for, remember we said x follows geometric distribution with probability of success 2 over 3. That's the probability of obtaining a head. Right? P of x is less than or equal to 2. We can use this one as P of x equals to 1 plus P of x equals to 2. But using our results, remember our first result, we can rewrite this A as P of x is less than or equal to 2 is the same as 1 minus P of x is greater than 2. P of x is greater than 2. And this will be, remember we want those items which is greater than or equal to 2. But we don't want everything that is greater than 2. So we can subtract from 1 whole because all the probabilities, both success and failure, add up to 1. So we can say 1 minus, remember our first result was P of x is greater than r is equal to q to the power r. So that will be 1 minus q to the power r, which is 2, which is 1 minus our q in this case is 1 over 3 to the power 2, which is 1 minus 1 over 3 squared, that's 1 over 9, which is 8 over 9. But in this case, you can also use this method, or we can say P of x is less than or equal to 2 is the same as P of x equals to 1 plus P of x equals to 2. Remember, P of x equals to 1 is the same as P plus P of x equals to 2 is the same as Q times P, right? And this one, our P in this case is 2 over 3 plus our Q in this case is 1 over 3 times P 2 over 3, which is equal to 2 over 3 plus 2 over 9. Then if we take our common denominator 9, 3 into 9 goes 3 times. 3 times 2, that's 6, plus 9 into 9, 1. 1 times 2, that's 2, which is 8 over 9 again, right? So you can use either this method from important results, this one is q to the power 2, or you can use addition method, right? Then now we want to part B. Part B. Our B, P of x is greater than 4. This is the same as q to the power 4, which is 1 over 3 to the power 4. Remember result number 1, this will be q to the power 4. And here we have 1 to the power 4, that will be 1. And 3 to the power 4 is the same as 81. Then C, P probability of x is greater than 7 stroke x greater than 3. This is the same as, remember, we said P of x greater than a plus b stroke x greater than a is the same as P of x greater than b. So in this case, a will cancel each other with a. Then 7, remember 7 is the same as 3 plus 4. So here in this case, we remain with P of x is greater than 4. 3 will cancel each other with another 3 here. 7 can be written as 3 plus 4. 3 will cancel each other with 3. Like here, a will cancel each other with a. Then we remain with b. So in this case, we also have q to the power 4. Remember, this one, we said P of x is greater than r, it will be q to the power r. So that will be 1 over 3 to the power 4, which is 1 over 81 again. Right. So this is how we use these results. Okay. Okay, now let's move on to expectation and variance. Without wasting much of our time, let's look at expectation and variance of a geometric distribution. Right, expectation and variance. Remember, expectation, we can write it as E of x, and variance, we can write it as variance of x. Expectation of geometric distribution is given by 1 over p, and this one is given as q over p squared. These are the formulas for expectation and variance. If p of x equals to x, is when x follows a geometric distribution. When x follows a geometric distribution with probability of success p. Right, so let's have an example. Example number 1. If x follows geometric distribution with 1 over 5, find E of x and standard deviation. Find E of x and standard deviation. Right, for E of x, solution for E of x, remember we said E of x is the same as 1 over p, which is 1 over, our probability of success in this case is 1 over 5, which is 5, right? Then variance of x is given by q over p squared. Q over p squared. Our q in this case is 4 over 5 divided by p squared, that's 1 over 5 squared, right? Now we have 4 over 5 divided by 1 over 25, which is 4 over 5 times 25 over 1. Then 5 into 25 5, which will be 20. So now, therefore, our standard deviation is equal to root of variance of x, which is square root of 20. Then square root of 20 is the same as 4 times 5, which is 2 root 5. This is in said form. If the question asks you to leave it in said form, but if it asks you to give your answer to 2 decimal places or what, then you just punch in your calculator, right? Another example. Under expectation and variance. Right, example number 2. The random variable x has a geometric distribution. The random variable x has a geometric distribution with mean 8. Find p of x equals to 3. P of x equals to 3. In this case, we have to find the probability of success and the probability of failure. Solution, right? Remember, we said mean is the same as expectation. So in this case, we have our e of x equals to 8, right? But e of x under geometric distribution is given as 1 over p, that's equal to 8. So if we solve this one, we get our p equals to 1 over 8. Then our q is equal to 1 minus 1 over 8, which is 7 over 8. Therefore, p of x equals to 3 is given by q squared. Remember, 3 minus 1 times p, which is equal to our q, that's 7 over 8 squared times 1 over 8 is equal to, we can punch this in our calculator. 7 over 8 squared, 7 over 8 squared times 1 over 8, 49 over 512. That will be our probability of x equals to 3. Right, thank you for watching this video. See you in our next lesson.